In LR3 and 4, we're going to learn the legal triangle shortcuts for proving congruency. So let's say we know triangle CAT is congruent to triangle DOG. That means we know angle C is congruent to angle D, angle A matches up with angle O, and angle T is congruent to angle G. We also know our sides match up, so CA, AT, and CT will be congruent to DO, OG, and DG. If I wanted to write a converse, then I could say if all of this is true, oops, I'm going to shrink that down so I don't run out of space, then triangle CAT is congruent to triangle DOG. But that's a lot of stuff to have to know. And so some mathematicians came along and they're like, I bet there's a way we can prove that we only need 3 things to get some congruent triangles. So here are all the ways we can have just 3 parts within triangles. Only some of them are going to be valid, and we're going to go through each one and determine which ones work and which ones don't. So side, side, side is when I have 3 pairs of congruent sides. Side angle side is when I've got 2 sides and the angle in between them. Angle side angle is when I know 2 angles and the side between them. Oops, that's not what I wanted, but that works. Side angle angle is when I have 2 angles and I have the side that's not in between the angles. So if I had something like this and a side out here. And then I get side side angle, which is when I have 2 sides and an angle not in between them. And then I've got angle angle angle, which is when I have all 3 angles and no sides at all. And again, only some of these are valid. So we're going to go through each one and talk about whether or not they work. So the first one is side, side, side. And if I follow this link, I can go ahead and slide this side, maybe, if it wants to work. Here we go. So I'm copying C over, A over, and B over, and then that pink triangle fits perfectly within there. Okay, so there's no way to form a triangle with those 3 sides. I'm keeping the length exactly as they are without getting a triangle that's identical to the first one, which means side, side, side works. So I'm going to go back up here and I'm going to color code it in whatever color means yes to me. I'm going to choose green. And I might even write valid up here so I know it's one that works. With side angle side, I'm going to keep the 2 sides and copy the angle over exactly as it is. And then the only way to connect the dots on those last 2 is with that same 3rd length. Okay, so the 2 sides are making sure they're proportional, and that angle is making sure that that 3rd side stays proportional as well. So side, side, side is also one that works. So again, this one is valid, and I'm going to make a note of that up here as well, so I can go back here and check which ones are valid and which ones are not once I'm doing my assignment. Wonderful. And then I've got angle, angle, angle. So I'm going to draw out any triangle I want. And I'm keeping those angles exactly as they are. I'm not changing them at all. But it's possible for me to get a triangle that's not congruent. It's still similar, but it's not congruent. Okay, I didn't change the angles, but I was able to change the sides, which tells me that angle, angle, angle does not work. So I'm going to come back up here and find angle, angle, angle. and I'm going to scribble it out because it is not allowed. It's not valid. Going back to side-side angle. I've got an angle here, and even though I'm keeping that 30-degree angle, I am able to move that length A = 3 around. And when I do that, then I can make multiple triangles. So if I keep A at 5.7, let's say, I could make a triangle that lands at B1 or that lands at B2. And those triangles are not identical. They're not even close. So I have two different triangles there, but they have two sides the same and they have an angle the same, which tells me it's not valid because there are two different ways I could make a triangle with the same side lengths and one angle not between them. So side-side angle is not valid. So I'm going to come back up here, find side-side angle, and scribble that one out as well. So now I just need to think about angle, side angle, and side angle, angle. And if I have side angle, angle, so if I know this side, and I'm keeping those two angles. Well, we said before that angle, angle, angle didn't work because my sides weren't proportional. But once I have one side and two angles, I know that third angle has to be the same. And that side is going to keep it proportional. Because I know right away that these are similar because they have angle, angle, angle. And then because this side is the same as this side, I know that they're proportional as well. They're already similar, right, because of angle, angle, angle. But if this is 7 and this is 7, well, if they're similar and the sides are 7 to 7, well, that means they're congruent as well. So side angle, angle is also one that works. So I'm going to make a note of that. And I'm going to change this to a color that says, yes, it's allowed in my brain, which for me is green. And then the exact same thing happens with angle, side angle. We've already said that side angle, angle works. If I start with those two angles and the side between them, well, I'm still able to get my third side. And then I have the exact same scenario that I had with side angle, angle, where they're similar, and by having one side congruent, the whole thing must be proportional and congruent as well. Okay, so angle, side angle is also one that works. So I'm going to color code that one green. So when I'm looking at this, the only four I'm allowed to use are side, 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 angle, side, angle, or side, angle, angle. And you could absolutely list this as angle, angle, side as well. It really doesn't matter. So we're going to practice this a little bit. And I'm asked to write a congruency statement, and I'm going to have triangle something is congruent to triangle something by whichever shortcut I'm using. And I'm going to go ahead and copy that because I'm going to use it on every single problem. And I'm going to do some color coding. BC and DC match up. AC and EC match up. And then these angles are vertical angles. So I have two sides and the angle between them, so I know it's going to be side angle side. So I had the yellow side, I had a pink angle, and I had a blue side. And notice the angle is between the two sides, so out here I'm listing it between the two sides as well. And then I've got BD is my yellow side, or BC rather. And CA is my blue side. I'm going to list my other triangle in the exact same order. DC matched up with BC. CA matches up with CE. So I need to make sure that my letters are going in the right order. I don't want to flip one on the second one. We're going to practice this one, and there's actually two ways we could do this one. And we'll talk about them. So I've got a triangle here. They tell me AB is congruent to BC. They tell me this angle is congruent to this angle. And then I can either say BD is congruent to itself, or I could say, hey, this is an isosceles triangle out here. These base angles would be congruent as well. So I can either use side angle side and have my pink side, that yellow angle, and then that green side. Or I could do angle side angle, where I have my orange angle, my pink side, and then my yellow angle. In either case, I'm gonna have A, B, D, A and C matched up, so C needs to go first, B and B match up, and D and D match up. Same thing down here. It's still the same exact triangles, ABD and CBD. It's just whether I'm using that shared side or whether I'm using that isosceles triangle to find base angles. Sometimes this one's hard for kids to see, so I'm going to trace over it and split them apart. I'm going to do that in gray. So I've got a triangle here. I'm going to split this one off. And I'm doing the same thing over here. I've got a second triangle that's right here. And I'm splitting this one off. Wonderful. So right away they tell me, hey, MO is congruent to OR, and OS is congruent to PO, and then they both have angle O in it, and it's the exact same angle O right here. So I've got side, angle, side. So I had my green side, a yellow side, and the pink angle is between those. For my congruency statement, then I have P, O, R matches up with P and S match up, O and O match up, and M and R match up. A few more examples yet. This time, I have two sides and I have an angle that's not in between them. Okay, so this is side-side angle, which is not allowed. So I'm not allowed to use it. But instead of saying, nope, they're not congruent, I'm going to say it cannot be determined. Because theoretically, I could come along with a protractor and measure this angle and this angle, and then I have side angle side. So while I don't have enough information to say that they are congruent, I also don't have enough information to say for sure that they're not. So I don't want to make any assumptions, and I don't want to say for sure they're not. So instead I'm just saying, cannot be determined, I don't have enough info now, but maybe I get more later, and then I can determine it. All right, looking at this example, I have A and C that match up, D and B match up, and then both triangles have this side AC. So I have angle, angle, side here. Or you could call it side angle, angle, either way works. So my blue angle, my green angle, and then my pink side. My blue angle is D in my first triangle, my green angle is A, and then my last letter here is C. I need to make sure that matches up with the other one. The blue angle that matched up with D is B. The green angle that matched up with A is C. And my last letter then in that second triangle is A. Again, I'm asked to write a congruency statement. This one's similar to one that we did before. Again, I'm given this side is congruent to this side. these two angles are congruent. Because it's isosceles, I have a choice now. I can either say, hey, these two angles are congruent because they're base angles, or I can say, hey, you know what? This side's congruent to itself. Either way works. Okay, so again, there are multiple ways to solve this one, and that's okay. So I could do side, angle, side, or I could do angle, side, angle. Either way, I'm going to have triangle DAC congruent to BAC. I'm going to split this one apart again, just like I did before, because sometimes it's hard for kids to see which triangles we're talking about. So I've got A and B here, and D. And then I've got A, B, and C. So I'm given right away D is congruent to C, and B is congruent to A, and then they both have this side AB in it, and it's the exact same AB. So that's this guy. And so I've got angle, angle, side here, or I could say side, angle, angle. Either way works. So I'm going to have A, and that angle matches up with B in my second triangle. B matches up with A in my second triangle, and then D matches up with C in my second triangle. And I had side, angle, angle, or angle, angle, side. Either way works. This time I'm told that MT is parallel to AK and is congruent. Notice this symbol means congruent. The arrows means parallel. Just because it's parallel doesn't automatically mean it's congruent, and just because it's congruent doesn't mean it's automatically parallel. Because it's congruent, I know my red angles will, or because they're parallel rather, I know my red angles will be congruent. And then they also both have AT in these triangles. So I'm going to have this side, my angles, and then that blue side. So M and K are matching up. T and A are matching up. And then A and T match up. And I had a side, an angle, and then another side, or two sides and the angle between them. So that is side, angle, side. This time again I have congruent sides, or parallel sides rather. This is going to act like my transversal. So those two will be congruent. I can also prove my vertical angle is congruent, and I can prove these congruent. So I have all my angles, but I don't have a single congruent side. So I don't have enough information to prove that these are congruent. What I do know is that they're at least similar, and someone could come along and pull out a ruler and measure one side in each and say, oh, nope, they're the same, so they are congruent. So I don't want to say no, they're not congruent. So instead I'm going to say cannot be determined. All right, on this one I'm going to go ahead and split these triangles again, just like I did before. So I have this side, and B is here. And then I have this side, and E, all right, so I'm given right away D is congruent to C, and this side is congruent to this side, and then they both have angle A, and it's the exact same angle A. Right? It overlaps completely right here. So I've got angle side angle for this one. So I had my blue angle, my pink side, and then my yellow angle. In my first triangle, D and C match up. They're my yellow angles. A and A match up. And then that last angle rather would be E and B.